Okay, so two things in Lab Zero that might be new to you. The first one is Git or version control. The second one is unit testing, right? So let's start with version control. What are we doing? Why we are doing what we do, right? Previously in past years, and this is not just for 2SH4. In fact, this is the case for all computer programming courses in McMaster, ECE program at least. Students used to submit code on Avenue, right? And then TAs look into the code, download it, try to make sure it works, maybe run it, maybe some of them will not run it and then go through it. And we also had physical demo. So you go to the lab session and then at the end of the lab session, you do a demo to make sure you did the lab. So now because of this virtual nature, and also because, to be honest, from my experience, I thought it wasn't the best experience to submit code through Avenue because Avenue is not designed for that. And it's not the kind of professional way. And also getting feedback from students that went for internships. They also wanted to get introduced to version control because this is what industry is doing. And any big project, you will find no one is not using version control in industry, right? If you are collaborating with like 10 teams or even like 10 members of the same team, you cannot just all name your code version 1 and then version 2 and send code by email. These things doesn't scale, right? So so what we do instead is we use version control. And the idea is very basic and it's in fact very beautiful, right? So maybe there are some details, but I don't want you to get immersed in all the advanced topics of version control because this can be a course of its own, right? But we are just using the basics to make sure you guys can have hands on that, and we utilize this as well to make the lab office hours, feedback, submission, grading more efficient. So we kind of have a twofold effect here. The first one is we get you introduced to something that is very practical. And then the second thing is we really use this in the course to make it more practical to discuss with you the code you have done, see all the history you have, auto grade to some extent, right? So what is version control after all this discussion? So assume the following. Assume you have a project and then you are, just for now, assume you have like a team of 2 members, but this can be 20 members, 200 members, but only 2 members also will make the point. So let's say, I don't know, this is Bob and this is, I don't know, Lacey maybe, anyone. So if both of you are collaborating together and they are not working on the same room, like everyone is working remotely or at different times or even in different countries, right? So what you can see is if you start developing, so assume we have our Lab Zero starter code here. So you have some basics of the code, maybe their documentation or the user requirements in the company, and then they get this in their local computer somehow. They start developing some of the code here. So let's say they add a block here, C0. This one adds a block C1. And then they try to, let's say the traditional way, every week they meet or they just exchange emails to start merging their code, right? To start making like the project is one entity at the end. Can you imagine if I just send this to, I don't know, the server or through email? I have C0 here, I start adding, so it's C1 here. They might overlap. So later I add another block of code. This one adds even another block. There are some overlaps. Let's see who changed what. There is a problem. Where the problem is coming from, it becomes a complete mess, right? So if it's a project that is big enough, it's going to be a complete mess. It's not going to work, right? So what is the solution? We have one of 2 solutions. The first one is, okay, let's say I can 100% split the code even between both. Like you have 10 functions, I have 10 functions. You might think this might work, right? And then you develop these 10 functions, don't touch the other 10. I do the other way around. Take the other 10 functions, don't touch your code. Does this work? In fact, not, right? Because those functions cannot be completely independent. Otherwise, this is not one big project. There must be an interface between the functions, right? So this alone doesn't work. So what else can we do? We can say we're going to meet at milestones, and then we put the functions together and start putting interface. But this, again, integration becomes much harder than what you might think, because the interface might affect your code itself. The way you develop your code will affect the way you read or write into other functions, and then things become a mess. Again, not scalable enough. The second completely different paradigm is we use version control. What we use version control, right? And what do we mean by version control? So what we do is you have a code in a repository. We call this the remote repository, right? In our case, your code is in the GitHub Classroom 2sh4 repository, like Lab 0, for example, the invitation that you got, right? And then everyone can get his local version of the code. This is the starter code you get in your lab when you do a git clone, right? So this is the git clone that you do. So what is git clone? So you have done this through Eclipse IDE, maybe, because you are asked to import a Git project and then give the URL, right? So this step we have done through an IDE, but if you have only a terminal, this command is the one that is fetching the project or the code in general from the remote repository, or let's call it now the centralized server. This is not a very correct naming because Git especially is decentralized, but let's forget about this for now. We have a centralized code base, which is GitHub now. You get the local version of the code, and this is a complete equivalent copy of the code, right? So when you get that Lab 0 starter code, look into it and look into your Git repository. It's exactly the same thing before doing any modifications, right? So it's a complete, honest copy of the remote code. And here, this will be in what we call your local repository, right? Good. This is the first step even before creating your Eclipse project. You just fetch the code from the repository. And then think of, we have maybe 300 students in 2sh4. Everyone is doing that, right? Everyone is getting his own local copy, exactly from the same starter code, right? And then the second step is you create your project, you start doing the development. So you add the two numbers in the function, you add the test in the unit testing, you run your code, you make sure it works correctly. So you do all these edits. These edits is done in a place that we call your workplace, right? So on your desk, there are two different things, the local repo and your workplace. This is where you do all the edits of your code initially, right? So in this part, you are not dealing with Git at all. In fact, you are dealing with Eclipse or writing C code, whatever the IDE you are using, right? But now you want to reflect these changes into the repository. For example, in Lab 0, you want to submit your code, right? So what do? I asked you in Lab 0 to do multiple steps. The first one is I told you to do a git add, right? So git add, and then the files you change it. This is going to take all the changes from your workplace into your local repo, right? So first of all, git add would say, okay, I have file 1, 2, 3, 4. So you create a list of the files you want to modify in the repository, right? And then after git add, you do a git commit. And then maybe here you need to provide a message, whatever. So git add and git commit, first of all, git add creates a list of the files you want to modify, and then git commit is going to put all these modifications from the workplace into your local repo, right? That means now your local repo became divergent or different from the remote GitHub account because you have modifications that is not there, right? Where do you do this git add? I will come into this, but let's focus on the concept and then we will come into what do we do actually in the coding, right? Then everything now is in your local repo, but it didn't reflect yet in the remote repo, right? So all of this, in fact, can be done offline. You don't need an internet connection because you are working locally in your desk. But you want me to see your code, right? You want the TA to see that you have submitted, right? And here comes the git push. So the git push is taking your local repo and then submitting this, updating the remote repository, the centralized one, with your changes, right? Does this make sense? So why this is great? This is great because, okay, in your lab, everyone is working individually, but again, if you are working on a collaborator, with a collaborator in a bigger project, everyone can, first of all, do his own changes offline. No one cares about what he's doing. And then you push your code, but others might have been already pushing, right? So there might be a conflict there, right? So people are doing different things to what we call merge or resolve the conflicts, right? So for example, I did a change, you did another change. If these two changes are in different places in code, so Git handles this completely transparent. You shouldn't even care, right? But if there are two changes in the same place, then Git will do a merge. What a merge means? Merge means basically the most up-to-date version of the remote repository will reflect both changes, right? So it helps in collaborating in projects. Good. So I guess from the questions you guys have, there might be things you missed, or the concept might be a little bit complicated for you. So let me try to repeat very briefly in a different way. I only need to care about, for now, 4 things, right? 4 different steps. First step is get, or maybe here, let me use a different color. So the first one is get the remote version into my own local desk or repository. And this is done through git clone. This is the first step. The second step is, after doing all my edits, developing my project, or you don't in fact need to wait until you end your project. One thing I advised you in Lab 0 is to make sure that every time you sit in doing the lab, you push after you leave, even if the lab is not complete. Why do we do this? Because Git want to minimize conflicts as much as you can. So for example, assume you are working in lab 1. Lab 0 is easy, so you might finish it in one sitting. But assume you're working in a lab that might take from you 10 hours, and then you allocate 1 hour per day. So every time you sit for 1 hour and then you develop without pushing into the remote repository, your local repository becomes very divergent from the remote one. So for example, if you lost your local copy, your disk, I don't know, is not working anymore, or you lost your code, there is no place to return it. And this is another advantage of Git. If you push frequently, even if during one step you kind of messed around with something that, for example, created you an error that you didn't have previously, you can very easy get back to the older version, which is the stable one, right? So how to do this? You use a git pull command, but this one we will come into it later. But one advantage is, if you assume I'm developing a question, it worked fine, but I wanted to try something else. So tomorrow I started developing some code. Oh, I created a problem. I'm trying to trace the problem. I'm not sure what is it. Can I go back to the older version? Oh, I cannot. In Git, you can very easily do that. How? By returning to an older version, because Git keeps track of all the commits you have done to your repository, and they give them a number. So you can say, I want my workplace right now to reflect an older version, right? Think of Git as, for example, the Dropbox or OneDrive of the code. In OneDrive or Dropbox, you can get the history of your files, right? It's exactly the same thing for your code, right? But in fact, in a more efficient way. So going back, so we said we care about 4 steps. The first one is git clone, which gets your remote repository, the Lab 0 starter code, into your local repository in your desk. The second one is, after doing all the modifications for the lab, you do a git add and then git commit. And the purpose of doing this is to reflect your workplace into your local repo. So here, all the changes you have done should be here in your local repo, but it's still locally, not pushed into the remote repository. So what you need to do, which is the third step, so this is 2 and 3, add and commit. And then the fourth one is the push. Push is taking these local changes and reflecting them into your GitHub code. You can check this yourself. For example, before doing a push, look into your GitHub web page, see the code changes, and then after you do a push, go back to your browser, look into your code. You will see it reflects the new changes. It gives it a new commit number, and it even in GitHub, it's very beautiful that it can tell you what exactly you have changed. Things look at green and red. If you added a code, it's green. If you remove the code, it's red. So you can compare different commits together, right? To be able to track what changes you have done. So these are the 4 things we need to care about in Git, right? So let me see if you guys have any further questions, and then I can move forward. Okay, I have already explained git commit again. If you're on Windows, git bash. What's the difference between git push and git pull? Okay. Are you going to show us with your screen? The local repo is still on your device, right? Yes, the local repo is locally, so it's in your device. That's correct. So all of this is your machine, is your hard drive. What is the difference between git push and git pull? Git push is pushing things in from the local repo. So, okay, so another number to make it, another color to make it easy. So we have 2 versions now, local repo, remote repo. Oh, that's a nice color. So git push is in this direction, right? This is a push. Taking things from local repo into the remote repo. Git pull is the other way around. You update your local repo with maybe changes that happened in the remote repo. Give again the example of you 2 are working on the same project. Before you set, you want to see if your partner made any changes to the code while you weren't working, right? To make sure you get the most up-to-date version. And Git pull is doing this for you. So Git pull is seeing what changes happened in the remote repo, maybe by other members, and then reflect this in your local repo. In our case, in our lab, sometimes I make changes to the starter code, right? Or even the test environment in the repository that I invited you to. If you don't do a git pull frequently every time you sit and doing the lab, you might miss these changes. So you will find in lab 0, I advised you that to do these. Now we have 5 steps because pull is the 5th one. I advised you to do these 5 steps all the time you sit with doing the lab. Start by pulling any updates before even doing any development in your code, right? Each time you set. And then once you do all the changes, do add, commit, then push before you leave. Tomorrow, when you come to continue in your lab, do a pull, all the changes, add, commit, push, and then make this your habit, right? Okay. Okay, so when you try to push things without changes, nothing will get pushed. So Git is clever in the sense that it knows what changes are there. Remember, you need to do add and commit before that. So if you try to do add without modifying anything in your code, it will not even do an add. It will tell you that, oh, no changes had happened. So you have up-to-date version. So it will not work. How do you do a pull? Just git space pull, right? Okay, so I guess now most of the questions are not imagining what's happening in real terminal. So let's jump into my Eclipse and see if things you guys, maybe some of you have already done the lab sessions, but let's look into the terminal together, okay? So let me here try to share. Where is my Eclipse? Okay. I hope you are able to see my Eclipse. Yes?
Yes.
Perfect. Thank you. Okay, so what do we do? Here, I'm in the folder of the lab exactly as you. Like, I assume you already get, you have imported your project, and then you look into the code, and you have your initial setup ready, right? So I want to start from the get point, right? So assume I changed anything. Like, for example, here, you are asked in the lab to develop some test, right? So I'm going just to copy this here, or maybe let's not touch the tests for now, because I want to explain this separately. Maybe I just go to the question itself, and then I do something like, I don't know, I change any line, right? Return input 1. I'm returning anything. So now I made a change, right? In fact, if you want to check if your local repository is different from your remote one, or if you have done any changes, you can do get status. This is another beautiful command that tells you what files you have modified, right? So here it tells you, oh, I modified question1.c. And then it tells you, oh, use get add or get commit minus -a to make sure you commit your changes to the local repo, right? So now what I'm going to do is get, oh, first of all, maybe you guys have a question of how even this terminal thing, right? So you have detailed steps in your lab 0 to obtain this terminal. One thing I have observed from your questions in office hours for the TAs is for the Mac users, Eclipse might be a little bit different in the terminal side. But for Mac, in fact, you don't even need to care about opening a terminal in Eclipse, because Mac has a Unix shell by default. Windows has this problem that they don't have a Unix shell that comes with the Windows operating system. This is why we have these extra steps to install the terminal within Eclipse itself. In your Mac, just open a normal terminal, and it's a bash or a Unix terminal by default, right? So open a terminal. I guess you can do this from, I don't like your search or command, or whatever the way you open a terminal in Mac, and then you just need to go to the folder where you have your local repository. Here I have it in 2sh4-labs, lab 0, and then my username, right? So the way you go to this folder from the terminal is just do a cd, right? So you cd, assume here I'm in, I don't know, in C, right? So I want to go to the get repository that I created for the code, that I cloned the code into. So I can do cd, then first I go to D, oh, but I'm already here. So, okay, so cd, and then D/ then 2sh4-labs, and then here you are in 2sh4-labs, and then cd, the name of the lab itself, which is this one. So cd command, it tells you which directory to go to, right? So you have to be in the same directory that you have the lab in. To check if you are really in the directory, because these are also problems I face in office hours, you need to make sure you are in the directory that you fetched the code into. To check this, you can do an ls command, which tells you what files you have in this current folder you are in. And here, these are the lab files. So I'm sure I'm the correct directory, right? So let's go back to get. So what do you do? So we modified something. Again, through get status, you are able to see what did you modify. Then you need to do a get add, and then either add all files or add only the file that you have modified, or just do asterisk, which is all, or do dot, which is the current directory. Everything might work, right? So I'm just adding everything. By only adding, this doesn't work, because I told you need to add, create the list of the modified files, but also commit, which takes the workspace into the local repo. So I do a get, commit, and then question1 modified, for example, any message you would put, right? Now, my local repo is reflecting the changes. I need to push this into the repo, right? So I need to do get push, right? Once you do a get push, it pushes things, right, to the far. So if I go back, if I go to my GitHub account, I would find that this change now is reflected there, right? Good. Okay, so this is all what you need to care about in get, right? So let me see if there are further questions. Yeah, okay. I guess ls is not recognized if you are opening a terminal in Windows that is not a bash terminal, right? So if you installed get terminal as, because there is a section how to get installed in your Windows, right? Bash is basically the terminal that takes Linux commands, right? If ls doesn't work, don't care, it doesn't matter. Just focus on the get commands. If get commands are working, that's perfect, right? So here, okay, let me show you something. If I just, okay, from here, assume I just close this terminal, right? And then I guess the way I can show a terminal, if I remember correctly, is from Windows and then appearance. Is that correct? What you guys have in your Lab 0 document? Show view. Terminal, okay. So here, when you try to open a terminal, it asks you what terminal you want, right? If you can get bash local terminal, I just pick local terminal, right? So the type of the terminal might reflect on what commands you can execute. But as far as get commands are going on, you shouldn't worry, right? So let me go back to the lab folder. Okay, so what else I wanted to show you, right? So let's make sure, like get push a kind of saving in local repo. No, get push is saving to the remote repo. Get commit is saving into the local repo. Get add, okay, again, just very briefly before we switch to the unit testing, because I know this might be a little bit confusing to you, right? So let me try to re-explain that. Get add is only creating a list of the files that you want to update in your repo, right? So it's just a list. It's nowhere. It's just a list saying, I want to update. For example, when I did a get add question1.c, it means I'm telling Git that, oh, this file I modified, I want it to be updated, right? But it doesn't make any changes to the local repo or the remote repo. And then get commit is modifying my local repo. Good. But the remote one is not updated yet, so it's all in my desk. You need to do a git push to make sure you transfer things from the local repo to the remote repo. I hope that's now clear. Okay, perfect. So by doing this, I guess it's a very, very introductory tutorial to Git. And if you have further questions, you can utilize the office hours for that. Yeah.